Hello and welcome. This is Cambridge O-Level Chemistry Paper 2, Theory section. This is May-June 2023 exam. The subject code is 5070 and this is variant 2 of the exam. Let's start. First question. It says, choose from the following oxides to answer your questions. So the list of oxides given to us is this. There is carbon monoxide, carbon dioxide, calcium oxide, copper oxide, ferric, ferrous oxide, H2O, H2O or water, sulfur dioxide, silicon dioxide, and zinc oxide. First part, it says each oxide may be used once or more than once or not at all. Okay, so but state which oxide is neutral. So the neutral, remember, water is a neutral oxide, H2O. Then reacts with calcium oxide to form slag in the blast furnace. So remember, silicon oxide is the one that reacts with calcium oxide to form slag that stays on the uh, surface that is removed during the process. So the thing is, so the oxide is silicon dioxide. Part C says reacts with warm dilute hydrochloric acid and give a blue colored solution. So warm dilute hydrochloric acid and reacting with an oxide that is giving us blue colored solution. So remember, if copper oxide reacts, so it will give us copper chloride precipitate, and that precipitate is blue in color. So the answer will be copper oxide. Then part D is amphoteric. Which oxide is amphoteric? So amphoteric is one that reacts with both acids and base and acids. Any oxide that reacts with both acids and base. So generally, zinc, aluminum oxides are amphoteric oxides. Say so zinc oxide is here. So ZnO is the oxide we are looking for. Then it says an oxide that contains ion with oxidation number of +3. Okay, so carbon. So let's write down the oxidation numbers of all the oxides over here. So for example, carbon is +2 here. Carbon is again +2 here. Calcium is +2. Copper is +2. Iron is +3. H2O is H plus. Sulfur is 2 positive. It would be 4 positive. S2, yes, S4 positive. And this carbon is 4 positive as well. And SiO2, Si is again 4 positive, and Zn is Zn +2. So the answer would be iron, Fe3, Fe2O3. Then it says decolorizes acidified aqueous potassium manganate, KMNO4. So potassium permanganate, and it decolorizes. So potassium manganate, if we add an acid to it, an oxide that forms an acid. Which oxide? So sulfur dioxide, it will form sulfuric acid, and that sulfuric acid basically decolorizes this KMNO4. So SO2 will be the oxide which we are looking for. Okay. Okay. So moving ahead, question number 2. It says group 7 includes elements fluorine, chlorine, bromine, and iodine. Part A says chlorine is green gas at room temperature and pressure. State the appearance of iodine at room temperature and pressure. So, iodine is generally black, grayish black in color, and it's solid state. It is a solid in nature. black or gray, black, solid. Okay. Then part B, it says chlorine reacts with aqueous potassium iodide in a displacement reaction. There's the reaction over here. Explain in terms of electrons why chlorine is an oxidizing agent in this reaction. So chlorine, so remember chlorine loses no. So it's an oxidizing agent. So oxidizing agent means that that entity must be gaining electrons. Gain in electrons. So we must or we need to see where is the gain in electrons. So chlorine is gas in aqueous state and Cl negative. So it basically has lost two electrons. So to become Cl negative. So sorry, gains two electrons to become Cl negative. So why chlorine? So the chlorine has gained two electrons to become to Cl negative. Again, or even it's just if you can write this, it would be good enough answer to get you the complete credit. Then state the oxidation number of iodine in I2. So it's a gaseous form I2. It is the oxidation number is 0. 0. Describe what is observed during the displacement reaction. So in this reaction, so the iodine has displaced chlorine from and there would be a change in color. So the solution or the color of the solution in this case will change from colorless to brown. Solution color changes from colorless to brown. Orange, you can also call it as orange. That is because of the iodine over there. So moving ahead, part C says the rate of diffusion of fluorine gas is greater than that of chlorine gas under the same conditions of temperature and pressure. State what is meant by the term diffusion. So diffusion is the movement of particles, also called as molecules when we are talking about gases, molecules or substance, any substance from a region of higher concentration to a region of lower concentration. Okay. This is the definition of diffusion. Then part 2, it says explain why the rate of diffusion of fluorine is greater than that of chlorine under the same condition. So fluorine gas is much lighter than chlorine gas. So we just simply fluorine, the molecular mass of F2 gas is much smaller than that of Cl2 chlorine gas. Okay, the lighter molecules diffuse faster. Okay, that is the reason why the fluorine gas is the fluorine gas has more rate of diffusion compared to the chlorine gas. Then in part 3, it says the rate of diffusion of fluorine increases as the temperature increases. state. Why? Using ideas about kinetic particle theory. So when the temperature increases, the average kinetic energy of the fluorine molecules increases. And as the average kinetic energy of the molecules increases, the number of collision increases, and that actually increases the rate of diffusion. So increase in temperature increases average kinetic energy of the fluorine F2 gas molecules, uh, resulting in more collisions, thereby increase rate of diffusion. Okay, so this is how you will answer this question. Next part C, 3, it says, this question is about preparation of salts. So first, they've given you number 8, zinc nitrate is soluble salt. Remember, all nitrates are soluble. It will come in very handy. All nitrates are soluble salts. Okay, so remember, this is a good thing to remember for the exam. This will help you a lot while in this part, in your paper 1 and in your paper 4 as well. So moving ahead, it says it is prepared by a reaction of an insoluble carbonate with a dilute acid. So zinc carbonate reacts with nitric acid, gives you zinc nitrate, then water and carbon dioxide. A sample of 4.5 grams of zinc carbonate is added to 50 centimeter cube of 1.3 mole per decimeter cube nitric acid. Show by calculation that zinc carbonate is in excess. Okay, this is pretty simple. So first of all, we calculate number of moles of ZnCO3. So then you have to calculate moles. So molecular mass of ZnCO3. So this will be so if we add zinc is 65, carbon is 12, plus oxygen 16 multiplied by 3, it comes out to be 125 grams. Okay, so 4.5 grams divided by MR. So the number of moles becomes 0.0636 moles. Okay, these are the number of moles of zinc carbonate. So number of moles of HNO3 or the nitric acid that are used. So we have 1.3 mole per dm cube, or one, and remember 1 dm cube is equal to 1000 centimeter cube. So it is also equal to 1.3 moles of into concentration, we have 50 centimeters. This is the concentration, so 1.3 moles divided by 1000 centimeter cube multiplied by 50. So now the units are same, moles and moles cancel, and the only remaining answer will be in moles. So our moles for this will be 0.065 moles. So from the equation, we can see that 2 moles of HNO3 need 1 mole of ZnCO3. Okay, so here we have to show that zinc carbonate is in excess. It means that we should be having zinc carbonate in excess, and there would be some moles of zinc carbonate less than 0.3 or some moles of zinc carbonate remaining out of these 0.036 moles which are available to us. So 2 moles of HNO3, it means we can also write 1 mole of HNO3 will need 1 by 2 moles of zinc carbonate, or we can say 0.065 moles of HNO3 will require 1 by 2 into 0.065 moles of zinc carbonate. So this comes zinc carbonate moles, and this is equal to 0.0325 moles used, which are used. The number of moles which are used is this. So moles of ZnCO3 remaining we have 0.036 minus 0.0325. So the moles of zinc remaining are 3.5 into 10 to power minus 3 approximately, or 4 point, or we can say that 0.4375 grams of ZnCO3 remains. So since this amount remains, this means that ZnCO3 is in excess. So if you're going to show, and even if you say that these moles are less than number of moles of ZnCO3 available, that would be sufficient answer for us over here. Okay, so moving ahead, it says part 2, it says once the reaction has finished, the mixture is filtered. State why the mixture is filtered. So we basically filtered it to remove the excess zinc carbonate. So to remove the excess / unreacted ZnCO3. Okay. Then it says, describe how you make pure dry zinc nitrate crystals from aqueous solution of zinc nitrate. So if you have an aqueous solution, the first step is to slowly heat the mixture till it reaches the saturated till it reaches saturated solution. Then allow it to cool. So remember, if we need bigger crystals, we allow it to cool slowly, and if we need mediocre size crystals, we allow it to cool in a little rapid manner. And if we allow very speedy cooling, then the size of the crystals will be much smaller. So allow it to cool slowly. Then you can see crystals will start to appear after some time. Oh, sorry for the spellings. After some time, filter the crystals from the solution, wash them, and dry using towel / filter paper or okay. So this is how you get pure zinc, dried zinc nitrate crystals from an aqueous solution of zinc nitrate. Okay, so moving ahead, part B, it says lead chloride is an insoluble salt. It is prepared using a precipitation reaction. Name two aqueous solutions that react together and give the precipitate of lead chloride. So remember, lead chloride is PbCl2. So a precipitation reaction means that there is either an acid or base, and then there is a salt. What? No, sorry. In precipitation reaction means that there is a salt that is formed, and that reacts with any of the compounds of the salt along with an acid. You can say all nitrates are soluble, remember, so you can use lead nitrate as one salt, PbNO3, and if you're going to add it into HCl, we are going to add lead nitrate into HCl, you will be getting a precipitate of PbCl2 plus HNO3 or nitric acid over here, or in maybe H2O and so NO2. This, yeah, so this is something what you will be getting, or in other way you can also add NaCl as well. So if you add salt or aqueous NaCl solution, you will be getting lead nitrate and sodium nitrate. So one case is lead nitrate. This is a soluble salt, and then you use any soluble, use this hydrochloric acid or sodium chloride. Okay, any of them will work. Then part C, it says ammonium sulfate. Ammonium sulfate is NH4 2SO4 is a soluble salt. It is prepared by reaction of an alkali and an acid. Name the alkali used and the acid used. So remember, alkali used here is ammonia gas. So ammonia gas, or no, I'm not saying gas in aqueous ammonia. That is the good way to saying it, or aqueous ammonia, and acid used is sulfuric acid because of the sulfate salt, H2SO4. So sulfuric acid, or generally it is dilute sulfuric acid, and aqueous ammonia will give you a soluble sodium sulfate salt. Okay, so moving ahead, question number 4. Question number 4 says that this question is about compounds that contains magnesium and nitrogen. So remember, magnesium and nitrogen. Number A, the formula of nitride ion can be written as N15 7 N3 negative. So complete the table below. So N, if we are also given a periodic table at the end of our question paper. So you can always refer to that. And this 7 is your atomic number. And this 15 is your actually mass number. Okay, so atomic number, so number of electrons is equal to number of protons, and atomic number is the number of protons. It is number of, or it is also the atomic number. Okay, so number of protons we have over here is 7. Then number of neutrons is mass number minus protons. So this is neutron is actually 15 minus 7. This comes out to be 8. So neutrons will be 8. And number of protons is equal to number of electrons. Yes, 7 would be ideal case, but we have a -3 sign. It means that it has gained 3 electrons. So it will be 10. So number of electrons will be 10. Then part B, it says why formula of magnesium ion is 2 positive rather than Mg positive and Mg3 negative. So remember, when ionization happens, the ion is in its stable form. So magnesium, if we know the magnesium, the atomic number is 12. So how the electrons are placed in the first shell will have 2, the next shell we have 8, and in the final shell, in the outermost shell, we have 2 electrons. So the magnesium will either gain 6 electrons or lose 6 electrons to uh, become a stable. So gaining 6 electrons will make it as 8. That is difficult for it. And it will easily lose 2 electrons and go in its 8 or the octet or the previous stable shell. So that is why Mg2 positive. So how we are going to write it? So we can say magnesium lose 2 electrons to have a stable outer shell with 8 electrons, making Mg2 positive ion a stable one as well. Okay. So if we lose 2 electrons, the magnesium will become Mg2 positive, and that magnesium 2 positive ion will be stable as well, because the outermost electron of the magnesium will be having 8 electrons. So part C, the formula of nitride ion is N3 negative. Deduce the formula of magnesium nitride. So remember, magnesium was Mg2 positive plus N3 negative. This goes Mg3 and 2. This will be our answer, Mg3 and 2. Then it says magnesium nitrate, MgNO3, is an ionic compound. Predict 2 physical properties. Remember, physical properties of magnesium nitrate. So magnesium nitrate, physically, it's soluble in water. All nitrates are soluble. Soluble in water, that is one. Again, it's an ionic compound, conducts electricity. That's the easiest thing you can write about an ionic compound. It's conduct electricity. Also, you can say high melting point, high boiling point. Also crystalline in shape, crystalline solid. Magnesium nitride is also crystalline solid, or white crystalline. It's actually white in color as well. So these are the things you can write. My choice will be the first two, soluble in water. Then number 2, conducts electricity when dissolved in water. When dissolved in water. Then part E, it says calculate percentage by mass of nitrogen in magnesium nitrate. So magnesium nitrate is MgNO3 2. It comes out to be magnesium is 24 plus 2 multiplied by 14 plus 16 into 3. This comes out to 148. If we are going to add all of things together, so percentage of nitrogen. Nitrogen is 14 multiplied by 2 divided by 14, because we have 2 atoms, nitrogen 1 and 2 comes from here, into 100. So the percentage comes out to be 18.918%, and it says 2 significant figures. So this comes out to be 19%, rounded off to the nearest to 19% percentage by mass. is 19%. Okay. So moving ahead, question number 5. Question number 5 states that the carbon reacts with steam to make carbon monoxide and hydrogen. This reaction is reversible. The forward reaction absorbs, remember, absorbs thermal energy, means that it is endothermic process. And then we are given, so this is solid, this is gas, gas, gas. So if you're talking about gases, so I have 1 mole of gas here, one here, one here. So total of 2 moles of gases here, 1 mole of gas again. This is solid. So then part A, it says equilibrium mixture is formed when a reversible reaction happens in a closed system. Okay. Explain why the reversible reaction must be in a closed system for an equilibrium mixture to be formed. So just think about this reaction. If this is not happening in a closed container, there, for example, you are giving carbon, the carbon is there, you are adding water and you're heating it. What is happening? The gases are produced and uh, carbon dioxide, carbon monoxide, and hydrogen are produced, and they are just leaving the system. So what you are getting? More gases are produced, and you are just taking it out. So basically, your forward reaction is going. There is no backward reaction, or there is very little backward reaction that is happening. So what if the system is closed? So if a system is closed, so once the reaction starts happening, as the forward reaction goes, also the backward reaction goes at the same time till it becomes a balance, or you can say the rate of forward reaction becomes equal to the rate of backward reaction, and that there's when then equilibrium is achieved. So what happens here that in case the system is not closed, that it will not allow the system to reach equilibrium, because the products or the reactants may escape into the surrounding. So this allows the to explain why the reversible reaction must be in a closed system. So this allows the reaction to reach equilibrium as the reactants and and products are contained inside and are not allowed to escape. This keeps the forward and backward reactions to happen at the same time without changing its rate. So this is uh, the way in which you can explain. I mean, if you have to explain it a very simple line, you can just simply say that a closed system does not allow the reactants or products to escape, thereby keeping the equilibrium inside the system. Then part 2 says predict what happens to the position of equilibrium when temperature is decreased and the pressure remains constant. So remember, this topic is from the Le-Chatelier's principle. Le-Chatelier's principle. Okay. You have to remember this. So our equation was carbon in solid form, then we have H2O in gaseous form, we have forward and backward reaction, we have carbon monoxide gaseous form, and we have hydrogen gas that is produced. So this one was our system. So what happens to the position of equilibrium when temperature is decreased? And this is an endothermic process. Okay, this is an endothermic process. So if temperature is decreased, it means that uh, forward reaction has increased. So forward reaction has increased. How the system will balance? So if my forward reaction is increased, the system will increase the backward reaction to compensate that. Okay. So what will happen? So if my temperature is decreased, the system will consider or will think that there is some this from forward reaction, and that is since endothermic reactions the temperature surrounding decreases. So in to compensate this decrease in temperature, the backward reaction will increase. So let's write it down. So the prediction will the backward reaction will increase. Okay. So the prediction, so forward reaction is endothermic, causes decrease in temperature. To compensate the decrease in temperature, the to compensate the decrease in temperature, the backward reaction will increase to bring the system back to equilibrium. Okay, so this is how you can write this. So next question, it says predict what happens to the position when the pressure is decreased and the temperature remains constant. Again, C plus H2O forward backward CO plus H2. This is gas, this is gas, this is gas, and this is solid. So what will happen to the if the pressure is decreased? So if my pressure is decreased, so when we are talking about pressure, we basically see what are the number of moles on each side of the equation. So we have 1 mole of gas on this side. We have 2 moles of gas here. Okay, so 1 mole of gas, 2 moles of gas are here in this manner. So if the pressure is decreased, so what will happen? So basically, if there is a container and there is an X amount of pressure, and this pressure is basically primarily because of these 2 moles. If say there are 3 moles of gases, the main constituent of pressure is these 2 gases. So if I am decreasing the pressure, if it means that number of moles of these gases is decreasing. So if the number of moles of output gases is decreasing, it means that the forward reaction will so it means that the backward reaction is actually increasing. So or basically the gases are consumed. So what will happen? So the prediction is to compensate this backward reaction, the forward reaction will increase. So the prediction is what will happen? So forward reaction will increase, or you can also say towards right. Right, the equation. Reason being, the decrease in pressure results from the backward reaction. The decrease in pressure results from backward reaction as the number of moles are more on the right side. This is compensated by the increase in forward forward reaction. Okay, so again a little bit explaining it a little more. So when the pressure is decreased, so pressure decrease means that in a container the number of moles of gases has decreased. So what causes decrease in number of moles? So if we are moving in forward direction, our number of moles of gases are going from 1 to 2. Whereas if we are moving from right to left, or if we are moving backward, our number of moles of gases is changing from 2 to 1. So which is a decrease in pressure? So decrease in pressure, the number of moles of gases are consumed to generate less number of moles. This is what it is happening. So to compensate it, or to generate, or to bring the case back to our equilibrium, the forward reaction will start to increase. Then question number B, the part B of this question, it says, predict what happens to the rate of backward reaction when temperature is decreased and pressure remains constant. So if the temperature is so that the again let's see, carbon, this is solid, it reacts in presence of H2O, carbon monoxide, and also get H2 gas. Okay, H2 gas, get H2 gas here. So what happens if the temperature is decreased? So when the temperature is decreased, so the temperature decreases, causes forward reaction, causes backward reaction to increase. So the decrease in temperature, what happens? So a decrease in temperature results in particles having less average kinetic energy, which causes less number of effective collisions. or reactions to take place. So basically, if the temperature is decreased, the rate of backward reaction also decreases. So simply uh, backward reaction, rate of backward reaction decreases. Okay, so decrease in temperature causes um, decrease in temperature results in molecules as particles having less average kinetic energy which causes less number of effective collisions to take place. Thus, the rate of reaction decreases. Okay, so this is how we do it. So irrespective of the forward or the backward reaction, if the temperature decreases, the rate of both of these reactions decrease. And in this manner, again, the equilibrium of the whole system is kept. Then part C says, what happens to the rate of backward reaction when pressure is increased and the temperature remains constant? So again, remember, this is solid H2O. This is in gaseous form. This is forward reaction. This is backward reaction. CO, gas, and you have H2, H2 hydrogen gas. Okay. So what happens to the rate of backward reaction if the pressure is increased? So if I increased, say we have 2 moles here and I have 1 mole here. So if I increase the pressure, that will do what? So if I increase the pressure, the number of molecules per unit volume uh, will increase, and the number of collisions for the reaction to take place. Or you can also think in this manner that this reaction will have to keep the equilibrium, and in order to keep this equilibrium, the reaction will shift or in such a way uh, to compensate this increase in pressure. So in order to compensate this increase in pressure, the reaction will move from a place of higher number of moles to a low number of moles. So if my pressure is increased, so what is the direction where I'm going from high number of moles to low number of moles? And that reaction is that direction is the backward reaction. And that is what also the way in which you can explain this. So the protection backward reaction will increase. Backward reaction increase or increases. Explanation, you can say that the equilibrium will shift to compensate the increase in pressure. E, the reaction will move in the direction from higher number of moles to lower number of moles, which is backward reaction. Okay, this is one way of explaining. Another way of explaining is again that we have more number of molecules per unit volume will be there, resulting in more number of collisions for a reaction to take place. Okay, this is another way to saying that, but in my opinion, the upper version is a better version of answering this. But any of these two versions, if you will be writing, I think you will be getting complete credit. So moving ahead, question number 6. In this question, it is about the energy changes that take place during chemical reactions. Part A, it says nitrogen reacts with oxygen to make nitrogen monoxide. This reaction is endothermic. Remember, endothermic, in endothermic, the output and class energy absorbed. Okay, and that's how we feel cold. So, in this reaction, the reactants have lower energy. Then it goes upwards and somewhere here. These are my products. And the difference between reactants and the products is actually your enthalpy or enthalpy or change in enthalpy. The activation energy is the energy that is required. EA is here. You have on the axis, this is your energy. And this is reaction pathways, you can say reaction pathway. And this is how you label this diagram. So reactants come here, products come here. For an exothermic reaction, this changes. I'm also, although this is not required, but I'm also making a graph for you to make sure that you understand how it goes for an exothermic reaction. So for an exothermic reaction, the reactants are here, the products are here. So the reactants go something like this. So these are your products. These are your reactants. This is your activation energy. And this is your change in enthalpy. Or again, the axis remains the same. So this is for exothermic reaction. Because I mean, some other papers or you may be asked something like this, and it's always good to have a clear picture of that. So moving ahead, it says hydrogen reacts with bromine to make hydrogen bromide, calculate the enthalpy change of this reaction. So again, we have two bonds that are broken and two new bonds that are formed. So first of all, and some of the energies are given. So bond breaking. So the total energy in bond breaking is hydrogen, H bond that is broken 436, and also bromine bond that is broken 193. So total becomes equal to 629 kg per mole. Okay, this is the total energy. Then for bond formation. So how much the new energy in the bond that are formed? So the new energy is hydrogen bromide. That energy is 366. And there are two bonds. So two of these are formed. So multiplied by two. The total energy is 732 kilojoules per mole. Okay. And then change in enthalpy, delta H, is actually equal to bonds broken minus bonds formed. This is change in energy, or difference between the reactants and products. Energy of this is your reactants, and this is your products. Okay, so the reactants, the energy is 629, and your products is 732. The answer is minus 103 kilojoules per mole. So answer will be minus 103. So the change in enthalpy or delta H is this. Okay. So moving ahead, question number 7. Question number 7, it says ethene, but one ethene, but yeah, but one ene and but two ene are alkenes. Okay, that's confusing, but anyways, the display formula of ethene and but one ene are shown. Okay, so ethene is this, but one ene. So remember, but one ene is, since it is with the first double bond, it is one ene. So if I have to say but two ene, it means that the carbon double bond is with the second carbon atom. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. H, C, H, H. So 1, 2. So this is how but 2-ene will look to you. Okay. So state the general formula of the homologous series of alkenes. So alkenes, it's pretty simple. It is CnH2n. This ethene, it is CnH2n. So for example, C is 2. So it is C2H4. This is how the formula is correct. Okay, it says but one ene and butene are structural isomers. So these two are structural isomers. What is the meaning of the term structural isomer? It means that molecular compound having same it is molecular compounds having same molecular formula but different structural formula. Okay, this is what that is meant by the term isomer. Then it says draw complete display of the display draw the displayed formula of but2. Oh, again, so I have already written it for you. C dash C double bond C dash C tuck 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 1, 1, 1, 1, 1. H, 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 H. So this is 1, this is 2, this is 3, this is 4. So since this is with 2, it is but 2in. Okay. So in the exam, basically, you don't need to write these numbers. These are just for your own information and for your own knowledge that how you have to draw these structures. It says but1ene is an unsaturated hydrocarbon. So unsaturated hydrocarbon, why but1 is unsaturated? Because it has a double bond. So it contains a carbon-carbon double bond or double bond. Okay. Contains a carbon-carbon double bond between first and second carbon atoms. Okay. Then it says state why but1ene is a hydrocarbon. Because it only contains hydrogen and carbon atoms. Okay, that is why it is a hydrocarbon. Then part D, it says but1ene reacts with steam in presence of catalyst and reacts with bromine. Draw structural formula of the product of the reaction with steam in presence of a catalyst. Remember, this is a formation of alcohol. So butene in presence of steam will become butanol. So structural formula. So but1ene, C double bond C, C, C. All these are your hydrogens. But1ene plus H2O, H2O, water in the presence of catalyst. That is generally H2SO4. This gives us butanol. So C, 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 1, 10, 2, and OH. This is OH. Butanol, in a more easier manner, if you're in paper, it's good to write H. That is also easy. Make sure that you don't lose points. Generally, if you just simply write like without writing an H, just a bar, that also. And this is your butanol alcohol. Then again, draw the structure formula of product of the reaction with bromine. So instead of water, you have bromine here. So C double bond C. Okay. Then you have Br, Br. You have a catalyst. This is sulfuric acid. So what happens here? It is pretty easy. These bromine will go. One will attach here, and one will go here, and one will attach here. So bromine one will come here, bromine one will have come here, and this hydrogen will come here. So so how it will look like? It will look something like this. Bromine, Br, Br, C, C. Okay, and you can also call it 1, 2. So 1, 2, dibromo butane. Okay, yes. So 1,2 dibromo butane will be your product, and over here the product will be a butanol. And remember, you can also use a base over here, acid over here, any of these reaction. This is also an addition reaction. This is also called an addition reaction. Okay. Also, don't forget to add H here. So for simplicity, this is how you make this. Moving ahead, part E, it says ethene. Ethene, sorry, is a covalent substance. Draw a dot and cross diagram to show the bonding molecule of ethene. Ethene is C2H4. So you have two carbon atoms. And 1, 2, 3, 4 hydrogen atoms. So let's draw it in a bit. So this is your carbon atom. This is one carbon atom. So remember, in the outer shell of carbon atom, you have 4 electrons. Okay, and in the outer shell of one hydrogen atom, you have 1 electron. It is making a double bond with another carbon atom. It is having another C over here. So with the hydrogen bond, I'm making it with green. So hydrogen, assume we have 1 hydrogen over here. Assume we have 1 hydrogen over here. Assume we have 1 hydrogen over here, and assume we have 1 hydrogen. And let's say hydrogen electrons are related by a cross. So hydrogen is cross, hydrogen is cross. So let me put hydrogen is cross. So now, how many? And C is dot. This is your E. So one carbon atom, one carbon atom, one carbon, sorry, one carbon electron, one carbon. So how many? 1, 2, 3, 1, 2. So 1, 2, 3, 4 are here. So 4 are missing. So 1, 2 from this and 2 from this carbon atom. So now what we have? So we have 4, 5, 6, 7, 8. 8 are shared. 1, 2, 3, 4, 5, 6, 7, 8. 8 are shared. So this is now a balanced dot and crossed outer shell structure for this ethene element. Oh, sorry, ethene molecule. Then it says explain why ethene has a low melting point. So ethene has it has carbon-carbon double bond. It has weak intermolecular forces or van der Waals forces. So you can say it has weak intermolecular or van der Waals forces of attraction, or basically force of attraction. And basically, ethane's low melting point. So the thing is, what is low? It is when we are talking about low, we are basically comparing it with a reference. So ethene has a low melting point compared to the other alkanes or alkanes, especially in that series, attraction, compared to other ethene in the series or whatever. So, but anyways, overall, we can say that it has a weak intermolecular force of attraction as compared to ethane, for example. You can, in brackets, you can write compared to ethane. Okay, that will give a much better picture to the examiner that what exactly we are talking about. So moving ahead, question number 8. Question number 8, it says this question is about electrolysis. The table shows some information about electrolysis of 3 different electrolytes using graphite electrodes. Okay, so we are talking about graphite electrodes. Complete table 8.1. So okay, let's see. We have this. Okay, so this is my graphite electrode. Pardon my drawing. Little. This is a positive. This is negative. Say this is my positive electrode. This is my negative. This is anode. Positive side. This is cathode on the negative side. So for the first case, okay, Aqueous potassium, potassium iodide. Then I have dilute sulfuric acid. Then I have lead bromide. Okay. Okay. So what are the ions that are available to me over here? So let me write them. Aqueous potassium iodide. So I have K positive ion. I have I negative ion. Aqueous H positive ion. OH negative ion. So in dilute sulfuric acid, I have H positive ion, I have SO4 2 negative ion, I have again H positive from water, and I have OH negative. Then I have molten, so that means that there is no aqueous or no water related ion, so I have only Pb2 positive and Br negative ions. Okay, so now this is my whole, all these solutions are here. Okay, so this contains this also contains this, and in one case, this also contains this. Okay. Let me. So what happens here? First of all, in first case, so what will happen to a concentrated aqueous potassium iodide? So concentrated. So this is aqueous concentration. So potassium iodide. So at the anode negative ions will move to anode. So anode, these two will move. So if it's concentrated, it means that iodine will take precedence. Aqueous potassium iodide, iodine will also, or iodine will come at, or will be seen at the anode, and at the cathode positive ion goes there. Amongst the positive ion, hydrogen ion gives precedence, so hydrogen gas, hydrogen, or also call it hydrogen gas, can be seen at the, or the effervescence of hydrogen gas can be seen at the cathode. Then part two, we have dilute sulfuric acid. Dilute sulfuric acid at the anode, we have sulfate ion, and the OH negative, the OH negative ion will take precedence. And if OH negative ion goes, means that oxygen gas is released. So oxygen is there. And at the cathode, we got hydrogen gas as well. Okay, again, hydrogen, effervescence of hydrogen gas. And on the molten lead bromide, on the anode side, negative ions, bromine will go. So bromine, bromide ion will go and will result in bromine or bromine gas. And on the anode side, we'll get P positive, or the lead side, or basically the graphene, the graphite electrodes will be covered with lead. Then it says part B, it says give two reasons why graphite is a suitable material to make electrodes. It's a good conductor of electricity. Conductor electricity. Remember, it is also inert in nature. And it also has high melting point. Okay. Inert in nature, non-reactive, anything you can write. Then it says part C, aluminum is manufactured by electrolysis of aluminum oxide dissolved in molten cryolite. At anode, oxide ions react to make oxygen molecules. Construct half-ion equation of this. So oxygen ions, O2 negative ions, make oxygen gas. Okay. So oxygen ions will be they have two more electrons. So they need to lose two electrons to become a single O. And you have to balance it. So two more electrons and make it four. Now this equation is balanced. So half ion equation, 2O, 2O negative minus 4 electrons will give you O2 gas. Or you can also write this equation as 2O2 negative gives you oxygen gas plus 4 electrons Okay, this is another way of writing this equation. Any of these equations will give you complete credit, but make sure that your equation is balanced. Okay, this is the half ion equation. So moving ahead, question number 9. Question number 9, it says that a sample of clean dry air contains 0.04% carbon dioxide by volume. Calculate number of molecules of carbon dioxide in 480 decimeter cube of clean dry air at room temperature and pressure. 1 mole of gas contains 6.02 into 10 to power 23 molecules. So remember, this is PV is equal to nRT question. And thing to remember here is that at uh, at room temperature and pressure, 1 mole of any gas contains 24 dm cube of volume. Okay, so 1 mole of any gas at room temperature is that. So first of all, we have to calculate the percentage of CO2 in 480 dm cube of air. Okay, so the percentage of CO2, this is 0.04% by 100 into 480 dm cube, and this comes out to be 0.192 decimeter cube. Okay, and this is the volume of uh, carbon dioxide. So and remember, at RTP, at room temperature and pressure, 24 dm cube of CO2 will have 1 mole. So it means that 1 dm cube of CO2 will have 1 by 24 moles, and 0.192 decimeter cube of CO2 will have 0.192 divided by 24 decimeter cube of volume. So the volume or the number of moles, so these are moles. So the number of moles are this much, or we can call it as 8 into 10 to the power minus 3 moles. And 1 mole of gas contains these many molecules. So number of molecules is equal to moles multiplied by Avogadro number 6.02 into 10 to the power 23. You're going to multiply it. It comes out to be something as 4.816 into 10 to the power 21 molecules. Okay. So my answer, number of molecules will be 4.816 into 10 to the power 21 molecules. Okay, so this is how you solve this question. Then moving to part B, it says complete combustion of fuels such as gasoline makes carbon dioxide. One of the hydrocarbons is in the gasoline has a molecule formula C9H20. Considering the equation for complete combustion of C9H20. So again, complete combustion, it means that it is burning in oxygen, and the byproducts are carbon dioxide and water. This is the complete combustion equation. So now what we have to do is we just have to balance out this equation. Okay, how we are going to balance out this equation? So the key is now, so there is only 9 carbon and 20 hydrogen. So first of all, hydrogen is only coming here and carbon is only coming here. So 9 carbon will come here and hydrogen 20. 2 are here, so divide by 20 divided by 2, 10. So now find out how many oxygens are there. So 18 are here, 10 are here, 28. 28 divided by 2, 14. So 14 or this is 14O2 will be and the complete equations. 14O2 plus this is what you will be getting. Then it says higher level of atmospheric carbon dioxide increase lead to increase global warming. Get one adverse effect of global warming. I mean, there are many. Increase in global temperature. Okay. Uh, Melting of polar ice caps, rising of sea level. Yes, I mean these are good. Any one of these values will be good. Then it says describe how presence of gases such as carbon dioxide in atmosphere causes global warming. Carbon dioxide, so CO2 absorbs energy, or basically thermal energy to be very exact. Thermal energy from the earth and reflects it back. Okay. This reduces the escape of energy or thermal energy from Earth to the space, resulting in increase in global temperature, causing warming, global warming. Okay, so this is I would say is a good way or to answer this question. Then part D, it says carbon dioxide is removed from atmosphere from photosynthesis. State a word equation for photosynthesis. Photosynthesis, remember, carbon dioxide plus water forms glucose and oxygen. So carbon dioxide plus water, you form glucose plus oxygen. Okay, so this is a word equation for the photosynthesis process. Then last question for this exam, question number 10. It says proteins and PET are polymers made by reaction called condensation polymerization. In the diagram in figure 10 shows the structure of a section of a protein. Draw the general structure of amino acid monomers used in the protein. So remember the amino acid monomers will be the ones with the NH thing. So amino acid monomer will be this part, yes. So any this part, and I will not have. So this is really extra. So okay, let's draw it. So it would be C. Double bond C O O H. Then I have this functional R. We'll have this H, and then comes the NH2, NH2, okay, NH2. Okay, so the general structure of an amino acid monomer is something like this. Okay. Then part 2, it says proteins are polyamides. Name one other polyamide, nylon. Nylon is another polyamide that can be fixed. So moving ahead, it says PET is a polymer used to make plastic bottles. The diagram 10.2 shows the structure of PET. Name the linkage present in the PET. So this is ester linkage. C double bond O is the ester linkage. With the one with the NH is the amide linkage. One with the CO double bond O and CO is the ester linkage. Okay. Then it says, describe the differences between condensation polymerization and addition polymerization. So basically, you have to mention two differences. I'm writing try to write a couple of them for you so that you may be able to decide which of the two you'll be using. So on this side, I'll be adding addition polymerization. On this side, I'm using condensation polymerization. Okay. So this part involves joining of monomers with no other product as a result. Number one. So it requires monomers, uh, involves joining of monomers to form simple molecules. So remember, these simple molecules are not a product of addition polymerization. So second part, it has same empirical formula as its monomers. It does not have it does not have same empirical formula as its monomers. Okay. Part three, you can say uses monomers with C double bond. Uh, so uses monomers with carbon double bond, and here we can say that uses monomers with two functional groups. Uses with two functional groups. Okay. So moving ahead, the last part of this exam, it says describe two environmental challenges caused by disposal of plastics such as PET. So plastics, they are take long time to degrade slash decompose. This causes accumulation at landfills and oceans. Also, burning, if you're going to burning, or produces toxic gases. This is, I mean, all out of these two, you can write any two these points, and I think that you'll be getting complete grade for that. So this is all from this paper, number two, and I hope that you have learned something. And I wish that this whole video will help you in preparing for your final exams. And I wish you all the best for your exams. Best of luck. If you have any questions, please feel free to ask in the question section. I will be trying my best to upload further videos. Thank you very much for listening. Take care.